Today, we're jumping headfirst into a mathematical mystery. We're going to take a problem that looks completely, hopelessly unsolvable, and by following the clues like a detective, reveal the stunningly simple answer that was hidden there all along. So just take a look at this. Seriously, if you were faced with an equation like this, where would you even start? It looks like a beast, right? A mathematical monster? And you know what? It's designed to be intimidating. But today, we're going to tame it. And here it is, the monster in the flesh. It's what's called a degree 9 polynomial. All that means is you've got a variable, x, raised to the 9th power, which creates 10 separate terms. Now, what makes it so scary are all those unknown a's values. Those are called coefficients. Our first job isn't even to solve for x, it's to figure out what those hidden a's values are. But here's the thing, we are not going in blind. No way. Like any good detective, a mathematician has a set of secret tools. We're not going to solve this with brute force. We're going to solve it with a clever investigation. This table right here, this is our case file. It contains all the evidence we need. These 9 values are the clues that are going to help us crack this entire mystery wide open. Each one is an absolutely critical piece of the puzzle. So how do we use these clues? Well, we have a special tool. You can think of it like a decoding key. It's a formula based on a known mathematical principle that connects a polynomial's roots to its coefficients. Basically, it's a way to cross-examine our evidence. By running our clues through this key, we can force the identity of those unknown S coefficients out into the open. All right, it's go time. The investigation begins. We are now going to apply our decoding key to every single clue from our case file. Let's see what patterns emerge when we start cracking the code. Okay, we start with our first clue, where k equals 0. We take its value, which is 63, we plug it into our decoding formula, run the numbers, and what do we get? The result is 0. Interesting, but hey, it could be a fluke. Let's see. We move to the next clue, k equals 1. We take its value, 1764, put it through the same process, and look at that. The result is 0 again. Okay, now we've got a pattern forming. So we try the third clue, k equals 2, and once again, 0. The pattern holds. This is getting pretty exciting. At this point, we're just confirming k equals 3, 0. Our method is working flawlessly. How about k equals 4? Same thing, 0. It's consistent right across the board. K equals 5. Come on, you already know the answer, don't you? 0. Equals 6. Another 0. We are building an absolutely airtight case. Almost there, k equals 7. Tested and confirmed, 0. And now for our final piece of evidence, k equals 8. We run the test one last time, and boom, 0. Every single clue, when we test it with our key, gives us the exact same result. This is not a fluke. This is a massive breakthrough. So why does all that matter? All those zeros weren't just a coincidence. They were the signal. They were the breakthrough that revealed the entire hidden structure of our polynomial. And here it is, the final reveal from our investigation. The tests uncovered the secret identities of our S's coefficients, and it turns out almost every single one of them is simply 0, all except for one. The coefficient S2R is equal to 6. Now for the moment we have all been waiting for. Let's take these uncovered values back to our original suspect and see what this discovery has done to our mathematical monster. Remember this intimidating beast we started with? All those unknown parts that made it look so impossibly complex? Well, when we substitute the coefficients we just discovered, something incredible happens. Every term multiplied by a 0 coefficient just vanishes. It disappears, and our 10-term monster collapses into this beautiful, simple equation. X to the 9th power minus 6x to the 6th power equals 0. That's it. That's all that was ever left. After all that work, after cracking the code and following the clues, the entire mystery hinged on this one single number, hiding in plain sight the whole time, the number 6. We started with something that looked like a tangled mess and found an elegant, simple pattern right at its heart. It just makes you wonder, doesn't it? What other elegant patterns are hiding inside problems that seem impossibly complex?